Greetings, class. When we were last together, we talked about the word science. We defined it, and we explained it as a process that helps us to learn about the natural world. And we used as an example hurricane tracking as a way to show how science has progressed in our understanding of natural phenomena. Today I'd like to talk about a couple of different concepts. I'd like to talk first about the goals of science, and then I'd also like to talk about some of the tools that are so vital to a scientist. So let's first talk about the goals of science. These are the 4 goals of science. To investigate, which of course means to, learn about what's happening in our natural world. But more than that, it's also about understanding, not just learning about the natural world, but actually making sense of it. And beyond that, being able to explain it so that that knowledge can then be passed on to future generations. As well as, with that understanding and the ability to explain, it will enable us to be able to make predictions of phenomena and what might occur in the future. Now, how do scientists do those things? Well, there are 2 important skills that a scientist must have, and that's their ability to observe and to infer. These are 2 very important skills, and they're both very different, but it's sometimes dependent on each other. Let's define them first. What does the word observe mean? To observe means to notice and describe events in a careful and orderly manner. It's about using your senses. It's not about making sense of things or trying to process it in a way that offers an explanation. It's just the process of using your senses to study the natural world. Whereas inferences are a little bit different. Inferences are logical interpretations of what's been observed based on prior knowledge and experience. The problem is, every single human being has different experiences, different prior knowledge, biases and personal opinions that they bring forth that can sometimes contribute or cloud their ability to observe what's going on around them. For a scientist, it's so critical to be able to discern when one is observing and one is inferring. It's also important to be careful to recognize that our inferences are not becoming our observations. In science, there's an important place for observing and there's an important place for inferring. Let's break them both down. First, by looking at observing. I have a little video exercise for you. Watch this carefully and see how well you observe.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
I was planting my petunias in the potting shed.
Constable, arrest Lady Smythe.
But how did you know?
Madam, as any horticulturist will tell you, one does not plant petunias until May is out. Take her away. It's just a matter of observation. The real question is, how observant were you? Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
I was planting my petunias in the potting shed.
Constable, arrest Lady Smythe.
Let's try a couple of exercises. Let's look at this picture here. See how well we can observe. I bet as soon as you looked at this picture, your mind probably told you an entire story. However, the question is the story observation or is it inference? If you told yourself, the ship was in a collision or the ship exploded, have you made observations or have you made an inference? Inference, remember, is when you take what you've observed and you make sense of it. So we have to be careful. When we're observing, are we actually observing that which we can do with our senses, or are we going beyond to the next step? So, for example, I would probably assume that the ship was in some type of collision, but that would be an inference, not an observation. However, what are the observations that tell me that? Perhaps it's the large hole in the side of the ship, which can be observed, or the inward bending of the metal on the side of the ship, that can be observed, or the debris on top of the ship, or the life raft to the side. All those are observations, and together they help to put together a complete picture which becomes the inference. Let's try another example. How about this poor fellow on the bicycle here? As soon as you looked at this picture, I get you again. Probably put together an entire story. Your brain does it instantaneously. It's the most powerful computer ever made. We'll take all the observations and instantaneously record them, process them, fill in the missing pieces, and create an entire story. That's what human beings do, and that's what scientists do. But again, we have to be careful to make sure that our inferences do not become our observations. There's a place for both in the scientific method. Scientists do have to make sense of data, but we have to be careful sometimes to make sure that we are not putting our personal biases, our prior knowledge, our personal opinions into the data itself, because that can cloud our observations and lead to erroneous conclusions and misinterpretations of data. What do I mean by that? Let's look at this example. Let's say, for example, in class, we measured all the shoulders of all the students and we calculated the statistical average for each. I bet overall we would find the males in the class have broader shoulders than the females. That would be statistical data that's quantitative because we measured it, as opposed to qualitative data, which would be descriptive. Those would be observations because we're using our senses. However, if we were then to take a leap and say that the boys in the class are stronger because their shoulders are wider, that would be a misinterpretation of the data and will be clouding our judgment. So we have to be careful again in science to make sure that we discern between the two, observation versus inference. There's a place for both. To conclude for today, a little bit of perspective about observation and inference. Because remember, it really is all about perspective. Remember, everybody brings their own life experiences, their own prior knowledge to an observation. And there's always going to be more than one side of the story because we each have our own way of looking at the world. The trick for scientists is to be able to separate what they bring to the table from what they're observing. There's a time and place for both in the scientific method. A good scientist knows when to observe and when to infer. Because, like I said, there is always two sides to the story. For example, Mount Rushmore. Did you know there was another side to the story? In our next lesson, we'll talk about the characteristics of science.